Determine whether the relation is a function. Identify the domain and the range. Let's make sure that we first of all understand what the problem is asking for. The first key word that we encounter is the word relation. What is a relation? Well, a relation is just a set of ordered pairs. So in this problem, our relation is the set that contains the ordered pairs -4, 2, 5, 2, 4, 2, 6, 2, and -3, 2. I think it's easiest if we first of all identify the domain of this particular relation. What is the domain of a relation? Well, the domain is the set of all valid inputs. So in this case, what are the inputs? Well, our inputs include -4, 5, 4, 6, and -3. So the domain is the set containing those numbers, the set containing -4, 5, 4, 6, and -3. That's the set of all the valid inputs. What is the range? The range is the set of all outputs. So for the set of outputs, we want to identify the second numbers in our ordered pairs. So we have 2, 2 again, 2 again. All the outputs in this relation are 2. So the range is the set that contains the number 2. So even though 2 occurred 5 times, we only list it once. 2 is the only number in the range. The range is the set containing the number 2. Alright, so the last thing that we need to do is to identify, is this relation a function? So what does it mean for something to be a function? Well, a function is a relation where each x value corresponds to exactly one y value. Okay, so to determine whether this relation is a function or not, we want to go one ordered pair at a time. First of all, we have negative 4, 2. So we find negative 4 in the domain, and we see that it corresponds with 2. When we go to the next ordered pair, we have 5, 2. So 5 corresponds with 2. The next ordered pair is 4, 2. So 4 corresponds with 2. The next ordered pair is 6, 2. 6 corresponds to 2. And finally, our last ordered pair, negative 3, corresponds with 2. Notice that each x value in the domain corresponds with just one value in the range. There's only one line that comes from each number in the domain. So that means that yes, this relation is a function. Now some students get confused because we see that the 2 value is repeated, and so they think, well, no, this is not a function relationship. It may help you to visualize a graph of the function. Most people are familiar with the vertical line test, which says that if every vertical line intersects a graph at no more than one point, then the graph represents a function. What does it look like if we plot the ordered pairs in this particular relation? So I'll go ahead and draw the x-axis and the y-axis. And then we'll plot the different points in the relation. The first ordered pair is negative 4, 2. So start at the origin, go 4 units to the left and 2 units up. The second point is 5, 2. So 5 units to the right and 2 units up from the origin. Our next ordered pair is 4, 2. So start at the origin, go 4 to the right and 2 up. Our next ordered pair is 6, 2. So go 6 to the right and 2 up. And our final ordered pair is negative 3, 2. So start at the origin, go 3 left and 2 up. So if this were not a function, then we would be able to draw a vertical line that would pass through more than one point. But in this case, if we draw a vertical line through each of our points, we see that each vertical line just goes through one point. So that tells us indeed that this relation is a function. The graph of the relation passes the vertical line test.